So let's wind up this section talking about what happens if you damage this neural network that's associated with attention. So first I want to tell you about a disorder that's called Balint syndrome. So Balint syndrome occurs in people who get bilateral damage into their parietal lobe. And so if this was the sort of flow of the control of attention network back here when we were talking about the role of the parietal lobe, if you get bilateral damage in these regions here, presumably you're going to knock out these areas in the lateral intraparietal region. Okay, so what do you think happens if you knock out these brain regions? I think I said this a little while ago, but a natural thing might be like, oh, maybe you're going to have a hard time paying attention. Sometimes, you know, people who have attention deficit hyperactivity disorder maybe it's something like that. And no, it's much more severe than something like that. People who have Balint syndrome completely lose the ability to attend to multiple locations at a time, okay? So what that means is that at any given moment, they can only report seeing one object at a time. So the way you can kind of think about it is sort of like they have attentional tunnel vision. The idea is kind of like when they get locked onto a location, the rest of the world effectively goes dark, they see nothing else, and they're basically stuck there, okay? Because when they don't see anything else, they never have anything else to like really attend to out in the world or shift their attention anywhere. So they never really voluntarily move their eyes. So everyone look down at me at the corner. Like if I was a patient, I was attending there, I'd be kind of stuck and I'd see nothing else. If someone went like that, then I would move my eyes and I would now be locked here. I can't snap with my left hand. So here I'm going to switch again. So then if I'm attending here and then I would shift again and then like again. So once they're locked into location, they can't move anywhere else. But the thing that's interesting is they have totally normal acuity, depth perception, motion perception. They can recognize objects. It's not as if their visual system is a problem. It's not like they need glasses. It's not like they need contacts. It's not like they're an agnostics at anything like that. It's just that they have a problem with the way that they can attend to the world. So for example, if you showed them a complex kitchen like this, and you somehow got their eyes on the cheese, and you're like, what else do you see besides cheese? They'd be like, I don't see anything else. I just see cheese. They're like, you don't see the kitchen? No, I don't see the kitchen. You don't see the bread? There's bread. You don't see the fridge? I didn't even know there was a fridge. You and I, we could put like, here, try this out. Put your attention on the cheese. You can still probably, even without moving your eyes, notice the flowers, notice the stove, notice the cabinets, the lights, and so on and so forth. People with Balint syndrome, they are locked on. So here is a video of someone with such a disorder.
Can you grab it with that hand?
I can't tell.
Can you see it?
I can see it, but I can't tell it. I can't reach it.
You seem to do better with your left hand. And take a crack at it up here, if I hold it up closer. All right, how about now that you touched it with that hand, can you reach with the other hand and grab it? With your right hand?
With my right hand?
Uh-huh.
No, I can't.
If I wiggle it, does moving it help you at all?
Nah, well...
Yeah, it does a little bit. So motion sort of pulls you toward it, like.
Sorry about that. I thought this next part, I think, is what we want to watch.
What do you see here?
Yeah, here
A comb.
Mm-hmm. What do you see now?
Comb.
What do you see now?
Spoon.
Do you see the comb?
No.
Do you see the comb?
Yeah.
Do you see the spoon?
Mm-hmm.
What do you see now?
I see the spoon.
What do you see now?
Comb.
Do you see a spoon at all?
Yeah.
Okay. Can you see what? Just tell me what you see.
I see what looks like a blackboard with some writing on it.
Mm-hmm. And there is a blackboard with some writing right behind us. So when you lost track of what was there, you picked up whatever was right in front of you, I guess. And you can see the writing.
That's an important thing I want to point out, is that when this guy, when he was shown those two things there and he struggled and he lost them for whatever reason, his attention seemed to go behind the doctor, and what he then saw was the blackboard, okay? But what I hope you noticed, I should have prepared and brought more stuff with me. There's nothing in this room with me. Okay, I'm going to use a mouse and a key. That basically, when the doctor's like, what do you see, the mouse or the key? He'd be like, oh, I see the key. And then as soon as the doctor moves the mouse, then he's like, oh, I see the mouse. But he doesn't say he continues to see the key. But with you all, again, if I was like, hey, what do you see? You'd be like, I see a mouse, I see a key, I see a guy in a room. He's got some words behind him. Like, you see a whole lot more. This guy only sees one thing. So when you damage these networks, you don't have the capacity to have control over your attention in a lot of ways. And you have this thing called Balint syndrome, which again, this is what I mean by attentional tunnel vision. Another form of attentional damage comes from this thing that is called unilateral neglect. Now, this actually is a little interesting because it's an asymmetrical disorder, but it turns out that for people who damage the frontal and parietal lobes on their right hemisphere, will damage this, will get this disorder called neglect, okay? Here are some actually not just drawings, but some actual brain scans of a bunch of patients. This is the left hemisphere, this is the right hemisphere, and these color codings are just showing where the patients had this damage. And so you can see in all these patients that I'm about to tell you about in a second, they're all having damage in their right hemisphere, not in their left hemisphere. And it actually turns out, I haven't really told you all this so far, but that attention is much more lateralized in the right hemisphere than it is in the left hemisphere. The left hemisphere, as we'll especially talk about in a few weeks, is really involved in language production and language comprehension. The right hemisphere is much more involved in processing attention. And so damage to the right hemisphere is going to give you more attentional problems, whereas we'll talk about later, damage to the left hemisphere will give you language problems. Okay, so people who damage the attentional networks in the right hemisphere, effectively what they lose the ability to do is to attend to the left side of space, okay? Now, again, why is it that the right hemisphere damage will give you problems with attending to the left side of space? It's that same issue we talked about again, where the left side of space is processed more by the right hemisphere. So damaging the right hemisphere asymmetrically affects the left side of space. They can see stuff on the right side of space just fine. And people who have neglect, they'll have a lot of very interesting and peculiar behaviors. They will often only shave one side of their face. They will often and only eat half of the food on their plate. When they're initially, if they have a stroke or if they have a lesion or if they have a tumor or damage or whatever, it takes them a little while to remind themselves like, oh, I gotta remember to like take my plate and rotate it 180 degrees. Or I gotta remember that after I'm done shaving one side of my face, I gotta shave the other side of my face. The way to think about it is imagine that you and I were eating dinner and you cleaned your plate and you're like, yeah, I'm done. And I'm like, really? And you're like, yeah. I'm like, look down at your plate. You're like, okay. I'm like, are you sure you're done? And you're like, yeah, I see an empty plate. Of course I'm done. I'd be like, do me a favor, rotate your plate 180 degrees. You'd be like, what? I'd be like, yeah, just come on, bear with me. Just rotate your plate 180 degrees. You'd be like, okay, I can. It's kind of odd. And then you rotate, you're like, whoa, where did food just come from? How did that just happen? Like it's not something that necessarily is second nature. It takes a little while to get it. Recently, I read an article, I think this is adorable but very sad, about a dog that got unilateral neglect. And so the dog would sometimes eat food from only one side of the bowl. So their owner had to also rotate it so that it would eat the food that was once it got moved to the other side. And a real simple way that you can test and examine if someone has unilateral neglect is you can do this thing that's called the line bisection task. So if I were to ask you, like, draw a vertical line in the middle of this horizontal line, what would you do? You'd probably come right around here and do that, okay? What do you think a person with unilateral neglect is gonna do? Where are they gonna draw the vertical line? They're not gonna draw it right here, are they? They're gonna draw it right around there. Because to them, they're only able to attend to this side of the line that they're looking at, okay? You can even do a line bisection test where you give them a bunch of lines and you say, hey, do me a favor, bisect all the lines. And they'll only bisect the lines that are pretty much on the right side of space. They'll basically ignore the one on the left side of space. And again, you can have very well-educated people who have had a stroke or a lesion or something, and you'll be talking to them and you'll be like, hey, Michael, did you cross all the lines? And they'll be like, yeah. And be like, you sure? Yeah. You sure you got all the lines? Yeah, doctor, I'm sure I got all the lines. You don't want to take a second longer and maybe make sure you need to double check? No, I'm good. I got them. I know how to cross lines. They're completely convinced that they've done it just right, but in reality, they're missing about half of them that are on the screen. Similarly, if you tell them to draw a clock, house, a flower, they'll do a pretty good job, but only on half of it. They won't get the entire left half, and they'll just stop and be like, yeah, that's all I can do. I've even seen videos, I couldn't find it, of a patient who was asked again and again, draw a clock, draw a clock, draw a clock. And eventually the patient was like, how many times are you gonna ask me to draw a clock? Like, why do we keep doing this? Because unbeknownst to him, he kept drawing it in a fashion kind of like this, and he was completely oblivious to the fact that he was doing it wrong. Now, one thing though that is very interesting, and it's not been super well studied, but I'll just tell you a little bit about, is that imagine you showed these two houses to patients who had unilateral neglect. Okay, so imagine you're showing these two houses. What they're going to do, as you might suspect, is not really be able to tell you the difference between these two houses, because the thing that's different about them, the fire, is on the left side, and they focus their attention much more on the right side, right? So it turns out that if you actually show these sorts of houses to someone who has unilateral neglect, and you ask them what's the difference, they're going to be like, I don't know what the difference is. There is no difference. They're the same. And you're like, really? Like, nothing? And they're like, sorry, like, I don't see any difference between them. They look the same to me. And you go like, okay, well, here's a weird question then. Say you had to live in one of these two houses. Which one of these houses would you want to live in? And they'll be like, what do you mean? They're like, you know, let's just pretend, it's make-believe little world. These are two little fictitious houses. You got to pick one to live in. Which one are you going to want to live in? And the patient will be like, I don't understand. They're the same house. And be like, yeah. I understand they're not the same house, but do me a favor, just pick one. And they're like, okay, you realize they're the same house, so I'm going to be picking at random because to me they look exactly the same, right? And you'll be like, yeah. Just give me which house would you want to live in if you had to pick one? They'll be like, I don't know. I guess I'd want to live in this one. And you'll be like, really? Why? And they're like, I don't know. Just you told me to pick one, and so I'm picking this one. So what they'll do is they will pick the one that, you know, it doesn't have fire going on in it. But if you ask them to explain to you why are they picking the one that doesn't have fire in it, they're not going to really be able to tell you why, because what's going on is their ability to process this information on the unattended side of space, the side of space that they're ignoring. It's actually happening subliminally. They don't even recognize that their brain is processing it, but what their brain is able to do is, even without conscious awareness, is able to do some sort of information gathering about the world around them, which will have them be biased to say that they would want to live in this house than that house there. All right, so let me just double check time. Yeah, we're good. Okay, cool. So we're going to actually go ahead and we're going to stop there talking about attention. I should mention real quick, attention is probably my favorite topic in all of cognitive neuroscience, the illusions of change blindness, inattentional blindness, and patients who have Balint syndrome and unilateral neglect, I adore. It's actually a big part of the research that I do in my lab, except we just do it in virtual reality, but it's still just this sort of stuff. So hopefully you've gotten a little bit excited by it too.